What we'll do is now extend this a little bit, and we'll look at spanwise loading. For spanwise loading, we want to know how does the load vary across this rear wing as we go from center to outboard. We've looked at the CP graph, but that doesn't really give us, that only gives us sectional information. We'd like to integrate that over the surface. But we'd like to see it in a graph form where we have integrals at each station. So the first thing we'll do is we'll select the wing element that we'd like to take a section cut through, and we shall cut it with a plane. We can use a tool location here to specify location of the plane. We'll make it very near 0. I should make this 3. And we'll make the normal in the -1 direction. Okay. So we've got a plane created, approximately where we'd like to start our section cut. So we'll create a section cut, and you can see here we've created a section cut through this element here. We can make it a little bit bigger here. And what we'd like to do is take the integral over that entity. So we'll go to the predefined functions, and we'll go to integral line. We've selected our part that we'd like to integrate over, and we select the variable that we'd like to integrate, downforce. Now we have a single value. Now the next thing we can do is we have this single value for this particular section cut. We'd like to take and query that value across the span. So we can go back to our test function here, and we'll enter in test special 2D plot, the distance that we'd like to go, and the number of sections that we'd like to have, say 50. Now this section cut's moving across. We are integrating the values at each section cut and storing that into a query. So now that's done, we can close both these. We can go to our query tab, and we can now see we have a distance versus line integral. So we can go and create this as a new plotter. And we'll move this up here. We'll put it over top of the other one here. And we can turn off the display of that. So now what we've done is we've integrated from at each location we've integrated the downforce for that particular section cut and plotted that value, and then we've swept that section cut and done the same operation across the span. So you can see that our load drops off as we go outboard. We could do this for the other section cut, for the other wings element, in the same way. So we'll do a plane to a location, -0.001. Okay, we've got another section cut here, or for our second element, and we'll do the same integral again. Integral of a line, we'll call this a different variable now, integral line 2, and we'll integrate over the downforce. Okay, so now we have a new variable 121 at this particular section cut. So again, we select this entity with this section cut and go back to our command again and issue our test special 2D plot, the distance over which we'd like to go, and the number of values. And now it's moving this section cut, generating and integrating this value and storing it in a query. Okay, that's done across the span. Now we go to our query again, and we can see we have another one here. We can add this to this particular graph by saying that we'd like to add it to this one. So now we have two values. We have the flap and the main wing. You can see the flap actually is reduced load in the center line, picks up load, and then decreases out, where the main plane pretty much drops load all the way across the span. We can also go back to query and say that we'd like to operate on existing queries. So we could combine. So we'd like to say we'd like the scale factor of 1 times this one, and then we'd like to add it to 1 times the value of the second one. Okay, so we can go to plot now, and we can actually add this on top of this one here. So now we have a total. So we've got the main plane, the flap, and the total. We can go to the plotter now and look at the min and max values on the y-axis. and say I'd actually like my minimum to be 0. My maximum is okay. And we'll look at this as spanwise loading. Now we've got ourselves a spanwise loading of both the flap, the main plane, and the total as we go across.